friends, welcome to my channel. So in the today's lecture, we are going to discuss how we can perform conversion from logical address to physical address. Okay, in this video, we will discuss how we can convert our logical address into physical address. Okay, so let's suppose in my hard disk, I am having 5 processes. Process P1, P2, P3, P4 and P5. So in hard disk we have 5 number of processes. I want to execute process P1, P2 and P3. Okay, I want to execute process P1, P2 and P3. So what I am going to do? I am going to load these 3 processes from hard disk into the main memory. Okay, we are discussing how we can perform conversion of logical address to physical address in a contiguous memory allocation. Okay, in contiguous memory allocation. Okay, so what I am going to do? I am storing my process P1 here. I am storing my process P2 here. And I am storing my process P3 here. Okay, each and every instruction, okay, is going to store at some of the memory location. Each and everything in main memory is address. Okay, if you have to fetch some of the instruction of one process, we will be accessing that instruction with the help of address. Okay, like we live in home, we have home address. Similarly, in main memory, each and everything is address. Each and every instruction is stored at some particular address. Okay, with the help of that address, we are going to fetch that instruction. Okay, so this is how I am giving here memory addresses. Okay, your process P1 is stored from memory address 0 to 100 and your process P2 is stored from memory address 100 to memory address 300 and your process P3 is stored from memory address 300 to 400. Okay, so my question is how we are going to map from logical address to physical address. Your CPU is going to generate logical address. Okay, your CPU is going to generate logical address. Okay, let's suppose your CPU is currently executing process P2. At one particular point of time, your CPU can run only one process. Okay, so let's assume that at one particular point of time, your CPU is executing process P2. Okay, so it is going to give you the instruction number. That now I need instruction number 5. Now I need instruction number 8. Okay, your CPU doesn't know where your process is present in the main memory. At any particular place, your process might be stored in the main memory. Okay, there is not any fixed place that always your process P2 lies in the range from 100 to 300 memory address. Okay, this time your process P2 is stored in this range 100 to 300, and next time if you want your process P2, again it might ranges from 200 to 400. Okay, there is no fixed rule that your process is going to be always stored at one particular location. At any particular point of time, your process may be stored at any location. Okay, but your CPU doesn't take care of it. Your CPU never cares that where your process is stored in the main memory. Okay, if CPU is executing your process P2, it is going to give you just instruction number. Okay, your CPU says I now need instruction number 5 of process P2. Okay, this is not the headache that where process P2 instruction 5 is present in the main memory. So this instruction number which your CPU is generating, we call it as a logical address. It is a logical. Okay, it is logical address. Your user is going to request for the instruction number. You don't know where it is mapped in the main memory. Okay, so your CPU says I need instruction number 5 of process P2. So how do we know that where process P2 is present in the main memory? How we will identify the instruction number 5 of process P2? Because in main memory there are many number of processes present. How we will find the location of process P2 and how we will fetch the instruction number 5 of process P2? Okay, so what we have one base register. Okay, we have one base register. In this base register, which process your CPU is executing, you are saving the base address of this process. Okay, the starting address where your process P2 is starting. What is the starting address of its first instruction? You are going to save that in a base register. Okay, so how you will be getting the 5 instructions? 5th instruction of process P2. Firstly, you will go to the base register. From base register, you will get the starting address of the process P2. With the help of base register, you will know that my process P2 starts from memory address 100. Okay, and what you want? You want 5th instruction of process P2. Each instruction is given a memory address. And this 100 is the memory address of your first instruction. Okay, what you will do? 100 plus 5. Okay, this way we are going to get the 5th instruction of the process P2. Okay, you find out the starting address of the process P2 and you add which instruction you need. Okay, and sometimes what you can do, you can subtract to -1 also. Okay, I'm just giving you the basic overview that how we are going to fetch the instruction from the main memory. Okay, so this way you are firstly going to get the base register value. You add the instruction number which your CPU is required. Then you can go to that instruction number. Okay. With the help of the base register, you can move to your required instruction. Okay. So this is how we are going to convert from logical address to the physical address. Okay. This memory address is physical address. We have to map the instruction number to the physical address where actually that instruction is present in the main memory, which address you need to get that instruction from the main memory. Okay, that is actually the physical address where your instruction is located in the main memory. Okay, so this is how we convert from logical address to the physical address. You know, this kind of physical mapping, this kind of internal mapping, these base registers and all the addition of instruction number with base register, all these things are actually hidden from us. We don't even take care of all such things, all such mappings. We don't ever try to convert the logical address to physical address. Okay, we are using operating systems. Okay, we are using Windows operating system. So all this internal working happens at the back end. We never take headache of all these kind of conversions. Okay, so that's why we say that operating system give us good platform. Operating system is providing us good graphical user interface. We never take care of the things which happen at the back end. If you have to do all such things in your own way, then how complicated it is going to be. Okay, so this is how we can do conversion from logical address to physical address. And now let me tell you one more thing. We also have a limit register. We also have a limit register. Okay. We also need to take care that where your process P2 is going to be stopped, where your process P2 is getting ended. Okay. Limit register means where your process P2 is getting ended. Okay. Because we don't want one process to interfere with another process. Okay, if with the help of one process you are able to access some another process, so security of your process is broken. Okay, we also have to follow some set of security mechanisms. Each and every process shouldn't interfere with each other. All the processes should run independently. Okay, so limit register tell you where your process P2 is getting ended. Okay, you shouldn't move ahead. Let's suppose you are ended at 300. You cannot access 301 instruction. When you are executing your process P2, you cannot access instruction number 301. The maximum instruction you can access is 300. Okay, the instruction present at address 300. So we don't allow one process to interfere with another process. We also need to take care of security mechanisms. Okay, so I hope that you are clear with conversion from logical to physical address. If you have any query, I have mentioned my email ID in the description box. You can contact me on that email ID. If you like my video, please like, share and subscribe my channel.